Hi, welcome back to my YouTube channel. My name is Untitled Richie. Today we are continuing discrete mathematics and our discussion will still be on relation. Today before the video will end, we'll learn the inverse of a relation. Then we'll learn how to combine two relations. This will be a very interesting engagement. Please watch the video till the end. So we'll start things off with inverse of a relation. So we say if R is the relation defined on the set A as R equal to the ordered pair AB, where AB is a member of A, then the inverse of A will be BA, where AB is a member of A. So what is the meaning? It means that when you are asked to find the inverse of a relation R, you take all the ordered pairs and flip them. That's all. So if you have an ordered pair 2, 3 in a relation R, okay, 2, 3 in a relation R, then our inverse of R will be equal to what? 3, 2. I hope you get that. You just swap the position of them. That's the inverse of the relation. Now let's look at a sample question on this. They say if the relation R is defined on the set A, which is equal to 1, 2, 3, 4, as 1, 2, 2, 3, 3, 3, 4, 1. Find the inverse of R. Then find the inverse of R, the inverse of R inverse again. That means you find the inverse of R inverse. So now let's see what happens. So remember the relation is 1, 2, 2, 3, 3, 3, then 4, 1. So R inverse will just be equal to, we just alternate the position of the ordered pairs. So this will be 2, 1, 3, 2. When we alternate the position of this, it will still be 3, 3. Then this will become 1, 4. So this is R inverse. Now let's find, so this is the first one. The second one, the inverse of R inverse. The inverse of R inverse. So what is the meaning? It means we alternate the position of the R inverse again. So we'll take this R inverse, we'll alternate the position again. Get 1, 2, 2, 3, 3, 3, then 4, 1, 4, 1. So we alternate the position. Look at this. When we alternate, we still get the R part. So we can say that our R inverse, the inverse of R inverse is R again. I hope you get that. We'll solve another one on this so that you are abreast with the concept. So solve our second question. Please, you can pause the video and try and see if you get the answer. So if the set A equal to 1, 2, 3, 4 has a relation defined on it as R equal to the ordered pair AB, where A is less than B. But A is greater than B, where A is greater than B. So that means we'll find the ordered pair. Please check out my videos on relation defined on a particular set on YouTube. It will help you. Now, let's see. So we'll find the ordered pair AB, where the first one is always and always greater than the second one. So that's it. So the first one, R, will be equal to the ordered pair. So we can't pair one with any of them. One cannot relate any of this because one is less than all. However, 2 can relate 1 because 2 is greater than 1. So we can have 2, 1. Can 2 relate any of these things again? No. Can it relate itself? No, because it's equal. 1 cannot relate itself to because it's equal. Now we take, can 3 relate 1? Yes, 3 can relate 1. 3 is greater than 1. Can 3 relate 2? Yes. 3 is greater than 2. Can 3 relate itself? No, it's equal. Can 3 relate 4? No, it's less. Can 4 relate all of them? Yes. 4 can relate because 4 is greater than everything there. We say 4, 1, 4, 2, can have 4, 3. Can we have 4, 4? No, because 4 is equal to 4. Then this becomes our relation R. Then the second one, the inverse of R. So remember the inverse will alternate. So the inverse of this, the 1, 2, 1, 3, 2, 3, 1, 4, 2, 4, then 3, 4. This is the card. So the inverse of R will be A less than B. If you check, A less than B. So this is how we solve this. I hope you got the answer correct as mine. The next thing we'll do or we'll talk about is combining two relations. So the next thing is we learn how to combine relations. So we said two or more relations can be combined using one, their intersection, their union, and their difference. Intersection simply is the intersection of a set. The element in one set, the element which is common in the two sets becomes the intersection. Their union means we put them together. Then the difference between one set A and set B is that, so the difference between set A and set B is A minus B. And A minus B simply means that the elements that are in set A, but they are not in set B. Then B minus A simply means the elements that are in set B, but they are not in A. We are going to employ that ideas in combining relations. So we take a sample question, then you see how we apply these things. So we solve our first question on combining relations. So they say let set A be equal to 1, 2, 3, 4. If the following relations are defined on A as R1 equal to 1, 1, 2, 1, 1, 2, 2, 3, 3, and R2 is 1, 1, 1, 2, 1, 3, 1, 4. They say find R1 intersection R2, R1 union R2, then R1 difference R2. This does not mean R1 minus R2, no. R1 difference R2, then R2 difference R1. Now how do we solve that? So we have our R1 as this and our R2 as that. The first one say R1 intersection R2. So R1 intersection R2 are the other pairs that are in R1 and the same time in R2. So which other pair is that? We have 1, 1 here, 1, 1 here. We can write 1, 1. Do you have any 2, 2 here? 2, 2 is not here. 3, 3 here. 3, 3 is not here. So this will just be R1 intersection R2. Now the second one, we find R1 union R2. So this will be, we just combine them. So this will be 1, 1, the union, put them together. 1, 1, 1, 1 is here, 1, 1 is here. So we write. We have 2, 2, 1. Let's arrange them. 2, 1. I have 1, 3. Then I have 1, 4. Then I have 2, 2. Then 3, 3. So this becomes the intersection. We'll put the two sets together and avoid repetition. So the third one, say we should find R1 difference R2. So what is that R1 difference R2? The element that are in set A, but the element that are in the first relation, the other pairs that are in the first relation, but cannot be found in the second relation. So which other pairs are those? 1, 1 is here, 1, 1 is here, so we won't select that. 2, 2 is here, 2, 2 is not there. So 2, 2. 3, 3 is here, 3, 3 is not there. 3, 3. Then this becomes R1 difference R2. Now the fourth one, so we should find R2 difference R1. So this simply means that the element that are in set, the other pairs that are in relation, the second relation, but cannot be found in the first relation. So what are they? 1, 1 is here and is there, so we select. So we have 1, 2, 1, 2 is here, is not there. 1, 3 is here, is not there. 1, 4 is here, is not there. So we have 1, 3, then 1, 4. Then this becomes R2 difference R1. I hope you get that. I hope you get it. We'll take another one where the relation will not be given. The relation will not be given to you. You need to find the relation. then you solve all these things. So we'll solve our second question. They say, if the following relation are defined on the set A as 1, 2, 3, 4, as R1 equal to the ordered pair AB, where A is equal to B, and R1 is that R2 is the ordered pair AB, where A is less or equal to B. Then the first question list the relation R1 and R2. Then the B, find R1 intersection R2. Then R1 union R2. Then R1 intersection R2. Then R1 difference R2. Then R2 difference R1. So you have to first list the relation. So let's solve it. R1 is here, R2 is this. So our A aspect says we should list R1 and R2. So look at it. We'll find the ordered pairs using the element of the set A. That the first element in the relation must be the same as the second element. So that will be the self loop. Please check out my videos on self loops. Now let's go. So we have 1, 1. 1 is equal to 1. We have 2, 2. 2 is equal to 2. 3, 3. 3 is equal to 3. Then 4, 4. 4 is equal to 4. I hope you get that. That becomes our R1. Now our R2 will be the relation, the ordered pair AB, where A is less or equal to B. That means the first element in the ordered pair must be either equal to the second one or less than the second one. That's the meaning. Please check out my videos on a relation defined on a set on YouTube. Now let's go. Can we take 1, 1? Yes. 1 is equal to 1. It must be less or equal. So 1 is equal to 1. We can pair 1, 2. 1 is less than 2. 1, 3. 1 is less than 3. Then 1, 4. 1 is less than 4. I hope you get that. Now, can we pair 2, 1? No. 2 is greater than 1. So you can't pair 2, 1. But we can pair 2, 2. 2 is equal to 2. Can we pair 2, 3? Yes. 2 is less than 3. We can pair 2, 4. 2 is less than 4. Can we pair 3, 1? No, 3 is greater than 1. So you can't pair. 3, 2, no, 3 is greater than 2. Can we pair 3, 3? Yes. Because 3 is equal to 3. Then you can pair 3, 4. 3 is less than 4. Can we pair 4, 1? No. 4, 2, no. 4, 3. No. 4, 4, yes. Because 4 is equal to 4. You can pair 4, 4. Then this becomes the relation R2. Please check it well. Because when it is wrong, all this will be wrong. All this will be wrong. So now we answer our question. So we should find R1 intersection R2, union R2. R1 intersection R2. R1 difference R2. Then R2 difference R1. So, since we have found R1 and R2, we can answer our question. The first one says R1 union R2. So we combine the two and avoid repetition. So this will be equal to, let me bring it here so that it will be equal to, now we combine them. So we have 1, 1, 1, 2, 1, 3, and 1, 4. They are all here. Then there is 2, 2 in 2, 2 is here. So then we have 2, 3, 2, 4, 3, 3, 3, 4, and 4, 4. That becomes our R1 union R2. We put them together. Now we find R1 intersection R2. So the other pairs that are in R1 the same time R2. 1, 1 is here, 2, 2 is here, 3, 3 is here, 4, 4 is here. So we write it. So we have 1, 1, 2, 2, 3, 3, 4, 4. So you can be asked to draw a conclusion. You can draw a conclusion that in this relation, R1 union R2 is equal to R2. This is that. And R1 intersection R2 is equal to R1. You can draw a conclusion like that. Now let's solve the rest. So we find the third one, R1 difference R2. The difference between the two. So what is that? The elements that are in R1, but they are not in R2. That's the meaning. So the other pairs that are in R1 but not in R2. So 1 is here, 2 is there. 1 is here, 2 is there. 3 is here. 4 is here too. Then we can say our R1 minus R2 is an empty set. There is no any such difference. Then the fourth one, R2 minus R1, or R2 difference R1. So how do we do that? That's the element that are in R2 but are not found in R1. So we have 1, 2 is 1, 3 is here, 1, 2 is here, it's not here, 1, 3 is there, it's not there. 1, 4. So 1, 2, 1, 3, 1, 4. 2, 2 is there, is here, so it is not part. 2, 3. 2, 4. 3 is here, is there, so we'll write. Then 3, 4. 4 is there, so is here, is there, so we'll not write. Then this becomes R2 difference R1. I hope you get this. Please remember to subscribe to the YouTube channel and click on the notification bell so that anytime I post a video, you'll be the first to receive it. Play over the video and get a concept. Until we meet again.